Draft physics video. You're going to be kind of an overview video, and I'll try to do it in pieces. Not really trying, but just experimenting, just to accommodate my own problem. I got a back issue. I need to get off my feet, but not get entirely off them. And so I think I'll do this to fix that problem. Anyway, so before we start drawing, context. So there is in physics a established group of concepts, ideas, notions about how the universe works. And some of them include things that even the average person might know are potentially just made up, like dark matter or something. Most people might believe that that could possibly be an error, where other parts of physics that I would argue are just as poorly evidenced, just as made up, they're quite confident that they have the correct answer. Things like time dimensions, notions of interference, annihilation, antiparticles. So the context is there's a theory of physics that started somewhere around the 1930s that included Einstein's relativity and the opposing theory of quantum mechanics, at least in a form that Einstein found objectionable in that it implied all kinds of spooky action at a distance. Now, Einstein himself was proposing a theory of relativity, of gravity, that was in a sense a pretty spooky action at a distance theory, in the sense that he accounted for no cause for the gravity effect, and there was just this kind of I don't know, I mean, this common delusion that by saying it's bent geometry he somehow answered the question, as if that wasn't as bad as saying the invisible man's doing it, when saying it's bent geometry, in my opinion, is no better than saying an invisible mechanism of some strange and unknown kind is forcing planets to fly into suns. So it really wasn't an explanation. And the theories were supported by what I would claim to be exaggerated evidence, evidence that wasn't nearly as probing or as pointing as they claimed it to be, like the Eddington experiment demonstrating that gravity could bend photons. I don't think they've still, to this date, compiled any real evidence that any such thing is possible. There's also built into that a claim by Einstein that photons not only are affected by gravity, but that they are special in the universe, in that they are affected by it twice as much as all the other material bits in the universe. And I would argue there's no evidence for that. So the real point is that I'm going to give you an argument for a simpler diagram of causes. I'm not challenging what we know to be the effects. And in a sense, Einstein didn't create any new effect that has been proven to exist. He merely established what we already know and gave you a diagram, a simplistic diagram, a bowl, to describe what Newton had already established as a reliable fact of the universe. That is the inverse square law, the fact that the movement of these bodies is proportional to their distance in terms of the amount of force that affects them, and this is consistent with an idea of spherical convergence, much like a spherical explosion or a light bulb in reverse. And as I've often pointed out, you can find the inverse square law in a lot of effects. It's here. Okay, this hand is 4 times smaller here than it is at half the distance. It's 4 times bigger. And that's what gravity is doing. And that's all that Einstein's bent space is illustrating. It's not illustrating something magical. It's just an illustration of the inverse square law. Something clearly Newton could have drawn you a picture of it. He could have used lines converging and put circles around the equal spots and pointed out, look, it's a topographical map. It looks like you're drawing peaks and valleys. But that's not what you're doing. You're drawing how much force is affecting something at a distance. There are no peaks and there are no valleys. So there's a bunch of mystique that I'm arguing against. So it's much like, I'm feeling it is much like an argument against a well-entrenched religious perspective. And people are just not even open to a discussion about being minkies. You know, they're just going to run away from a conversation about what the facts really indicate versus what they wish or hope or have been trained to believe. The ideas and notions that they've become familiar with. And again, this is a lot of hero worship. You see it. People think Tesla was the great underdog, and so everything Tesla did was brilliant. And you know, there's in conventional physics defenders of Einstein, and then there's defenders of the competing model, quantum mechanics, and the Heisenbergs and the Schrodingers and the rest of them, and then they become their icons, and they just don't want to hear that they could have been fundamentally and catastrophically incorrect in what they were establishing or defining as causes for the effects. Now, you could argue that Newton is kind of immune to this critique because Newton was very careful about not making claims that he couldn't prove or he couldn't back up with evidence. So he made no claims about cause. He just described what he could make claims about, which are effects. And this is the big difference between science 300 years ago and science now, is that science is very willing to make claims that they can't really support with a volume of evidence. They just hope it's true. They feel it's true. They sense it in some way. It looks like interference, therefore it's interference. They're not very good scientists. So my obstacle here is substantial in terms of just trying to appeal to you to have an open mind and recognize I'm not challenging established truth. I'm challenging the part that isn't well evidenced, the claims made that are, in my opinion, much more phantasmagorical, much more human-centric, magical than the evidence indicates. And I'll give you the simple explanation as an opposition to their complex and magical entanglement. There's a seems a real endorsement of bringing back a bunch of the pseudoscience of mysticism and ESP, and that's all this entanglement notions, and the rest of it is going to get you. It's just a bunch of people who think they can see each other's neurons or something. They're entangled with each other's souls, and it just creates fodder for the remaking of another religion. So I can just appeal to you that your conventional physics does look like a religion. It has elements of it, that it is fanatical, and that it avoids any kind of challenges. It won't answer these questions. It won't be interrogated. So it shows the same closed-minded fear that the religious people demonstrate when challenged by evidence, and that there's good reason to suspect they may be wrong, merely because their evidence is so weak. It's such a thin line of it looks like, rather than evidence that it is like. Alright, so that's a little bit of a sermon to start with, and we'll see where we go from there. Alright, I'm back. So where to begin? So let's start over. Let's just look at the universe and try to analyze what we see. And I would argue that what you kind of see is a bunch of things you can see being pushed around by a bunch of stuff you can't see. So the forces, magnetism and gravity, and let's go with the third one that we don't think of as a force, but the light that we see, the electromagnetic spectrum, is obviously acts like a force. It has all the features of a force, especially when it's in forms that we can't see, that are invisible to us. We certainly see the ability of it to burn things or explode things or affect things, heat them and do things to them. So it, like gravity and magnetism, they all have a common speed. And what they don't have in common is something like frequency. And so we can identify differences, subtle differences between the forces. Gravity having just attraction, magnetism having attraction and repulsion, and being dependent kind of on some notion of polarity and having two different poles, a plus and a minus charge, so closely related. So some of this is going to point to the stuff we already know, like Maxwell's equations, a kind of half effort at combining magnetism and electricity. And I say a half effort because he left the two fields different, B and E, when they're really always expressed with the same force. The actual force that they call electric is the same as the force that magnetism uses. And I'd say the same as all the other forces. It's just a different presentation of it. It's made out of the same paint. The paint just has different colors. Lots of analogies. Same, dog is a dog is a dog, except there's breeds of dog, something like that. The differences are subtle, not substantial. But they can have substantial effects, these differences. So, back to the gravity argument. So Einstein's description doesn't have a force, doesn't have some sort of, like photons, a moving entity, even though it does create the effect through distance at a speed. So even though they don't have a defined force, they're basically saying that this geometry bends at the same speed that light propagates. Kind of a strange, kind of an obvious, there's something wrong with that notion of saying they're different things when they have this common speed. It just doesn't make any sense to have two completely different, let's say, animals living on different sides of the earth, and they would just coincidentally run at exactly the same speed but be related in no other way. Just too much of a coincidence. So gravity is obviously a force where things are converging, and the simple explanation is to go with this idea of push instead of a pull. Pull is a complex mechanism. I would argue that in everyday life, anytime you pull something, you can always find where you're really reaching around and pushing. That something's always getting pushed when there's a pull. And it's kind of like the pressure argument. When you reduce pressure, it's the external pressure that creates the movement. It's not the absence of pressure that's making something move, it's the excess of pressure somewhere else that makes something move. That it's a push universe in most of the ways we interact with it, for sure. And I would argue that that evidence is not lying to you. What you see in most of the universe, in terms of things hitting other things and pushing them, is in fact what the universe does. It doesn't pull anything. So gravity can be easily explained, the inverse square law, by just understanding it as kind of the opposite of a light bulb. Instead of the energy going out, the energy is pushing from the outside in. And that would explain why big objects get hot. It's because you can sort of understand that if there is pressure on the outside pushing in, it's pushing in conflicting directions, you know, this way and this way and this way and this way. And it would end up jiggling everything an awful lot, which is the nature of what heat is movement. So it explains a lot to understand it as an external force, that the force is a real thing, as real as photons. So if you want to believe they're some sort of propagation in an ether, I suppose that's okay. I don't see the necessity for it. But clearly that's what everything is this pressure created by these forces that have a discrete quality to them, a smallness, a tiny grayness to them. You can cut them into little pieces, and the little pieces don't get any finer, a little clump of energy. And they all behave that way. They all quantize, and you're really just talking about how much you're getting hit by will determine the effect on what we call matter. So I guess the point to be made is that you can understand the universe as being made of two elements. An element that moves the speed of light and that has subtly different properties when it's magnetic or electric or gravitational or in the form of photons. And it all moves the speed of light. It's all very granular. And then you have the stuff we call matter, which is the protons and the electrons and the neutrons, whatever other little bits you want to throw in for fun, but the nuclear bits, and they are being, just like the big universe, they're feeling the force, the external pressure. That's why they create these little pressurized atoms, and those atoms, like the big things, there's a consequence to being manipulated by the force. And the consequence is that they have a kind of energy stored in them through the process. They end up trapping some of the force. And that's a sort of an important concept. I probably am jumping a little ahead. But the idea is just recognize you have the little bits moving the speed of light, and then you have kind of dead bits that don't do anything except react when the force hits them. The force can attach itself to them. They absorb it. They can trap it in a circle, or back and forth, or up and down, or in some way. They take something, a little Speedy Gonzales flies into the house, a little rat moving the speed of light, and you make a trap. You make a little loop, and it just keeps going around and around and around in a loop. And in a sense, you possess the energy of that mouse, rat, moving the speed of light. And that's sort of the nature of what atoms do. So it's sort of in the nature of when you have a bunch of these particles, hard stuff, that doesn't have any innate speed, and you start pushing it around, you end up trapping bits between them, and those trapped bits are real energy. And that's basically how all atoms are created inside the densest, most pressurized part of the sun, and our suns, under very high pressure. And so it's a mechanism that has a bunch of tension locked into it, and the tension is survivable. And so we have 100 and so elements that basically describe the 100 or so ways you can arrange these elemental pieces, protons, neutrons, and electrons, in ways that are stable, that will be durable. When you take them out of the intense pressure, they'll still stay together. They can survive the transition. So still haven't drawn anything. So it's just important to understand that if you just start over and say, what was the evidence they had in 1930? Or even what was the evidence they had in 1801? and start putting it together, you can put together a mechanical mechanism that doesn't have conflicting mechanisms, bent space versus virtual photons that they use to describe magnetism. So an important thing to realize is that that's really what I'm arguing against, is the fact that you can sort of, that here they have something, the two most fundamental, the two most obvious forces we can watch is the magnetic force and the gravitational force. It's right there for us to see, and their explanation for them is, one of them is some sort of bent geometry thing, no description, and the other one, they actually say the word virtual photon, invisible, fake, not real photon, some sort of thing that makes it happen. And they don't explain how it makes it happen. They just call it a virtual photon because it does something. They know it moves, and it moves at a speed, and somehow it creates attraction and repulsion, depending on circumstances. But they have actually no model. They have no explanation. They have mathematics that describes what the effect will be when you put two magnets next to each other, or when you put a magnet next to a wire, but they have no mathematics that tells you why it happens. They have no explanation at all for the agent that makes it happen. And I can give you that. A very simple mechanism that explains why magnets attract, and doesn't change the fact that they do, and doesn't change what we have already established to be the effects of magnetism. It doesn't challenge that. You don't need to change the effects mathematics to accommodate the correct cause, or a cause, in this, a proposed cause. There could be other causes that fit. I'm just saying I haven't seen any others, and this one fits very well, the cause I'm going to give you. Alright, so we'll still wait. So I'll be back. Alright, let's try to get to the basic argument being made. So you could understand bent space in a lot of different ways. The basic mechanical fact is that if you were to draw it in different ways, you could understand that these rays are diverging with distance. So if you just thought about the energy at different locations, you could understand that you would intersect more lines the closer you got to an object, and less lines the further away you were. And so in a sense you could always draw the field of gravity much like a topographical map. The lines would get closer and closer and get further away and wider as you get further away, and have this appearance of a bowl shape or a peak. And all that's really illustrating is the fact that the force does get stronger as you get closer to the center, and that you can also understand that is if you had a random field of energy just moving in all different directions, it would end up, from everyone's perspective, the energy that hits you would all be coming right at you. So even though there's energy going this way and there's energy going this way and all kinds of different ways that this little stuff could be going, the only stuff that's going to hit you is stuff headed right for you from all locations, close or far. And so the appearance from your perspective will be very perfect, in the sense that it'll be quite radial, and there'll be more force closer to you than further away, more elements of it in this very coherent. So you can understand that if two objects were in proximity to each other in such a world where the force came from the outside and was pushing, they would essentially block force that was heading for the other guy, creating a kind of a shadow. And so there would be more force going this way than force going this way, because the amount of force going this way has been interrupted by the presence of the other object, and vice versa. And this would just cause the two things to be attracted to each other, when actually they're being pushed into each other, clearly. So this is called mock gravity, this idea. It was first proposed back in Newton's day. Even people like Richard Feynman concede it perfectly explains gravity. And the only problem with this idea of an external pressure is that it creates issues of drag, in the sense that objects couldn't travel through free space without encountering more force in the direction they're going than behind them, and therefore creating a problem in terms of maintaining a velocity in a field of energy. So if you have an ether that's moving, if you have little bits that have momentum as you move forward through it, again, the simple argument is you hit more stuff in the direction you're moving coming in the opposite way than you would ever hit coming the same way as you. The stuff going the same way as you obviously isn't going to be as easy to hit as the stuff you're heading towards. So anyway, I'd argue that there are ways to understand why that drag problem isn't a problem if you dig deeper into the subtleties of how this mechanism might work. So it is a perfectly sensible way of describing gravity, and it creates a real mechanism. Now we have some indication that this might be the real world, in the sense that there's cosmic background radiation coming from all directions, very much the same way as this radiation would be, the radiation I'm describing. And the only thing it lacks is enough density to account for the movement of the planets towards the sun. It wouldn't be enough to create the amount of acceleration that planets experience. But it's clearly a source, a way of recognizing there's energy we don't know about. Clearly Newton didn't know about it. Clearly even Einstein didn't know about it. And when he first proposed his theory. So it doesn't take much imagination to recognize that perhaps there's other modalities of this energy in the universe that we don't detect, because they don't come at a frequency. So that's the part I think I'll attempt to describe, is that the only reason why we see the cosmic background radiation, or the portion of it that we see, is because it has a signature. The pieces of it, the bits of the radiation, come at a frequency. And it's called the microwave background radiation. Is usually how it's described, because the bulk of it, most of it, is in the frequency that we recognize to be in the microwave range. There's lots of it still in the radio wave range, and I suppose there's some random photons also. Now, the trick of understanding what we identify as something existing is that it has to have this pattern to it. They took Hertz 7 years to find a way to detect radio waves. You can't just say, well, I know they exist and I'm just going to get them. You know, I'm going to make something move or make something happen. It's more complicated than that. So it can be quite a lot of radiation, and it's completely invisible. The radiation of beta and alpha, radioactive type radiation, it's all invisible. It wasn't detected. It takes some kind of mechanism or device you have to invent to be able to detect it, Geiger counter. Or otherwise you don't even know it's there. You don't even know you're being exposed to it. The way most radiation is detected is based on the fact that most of the electromagnetic spectrum is detected is because of the way it affects electrons and atoms, creates a voltage by changing the polarization of the atoms and causing what we call electric current. And so our eyes even work that way. And so the detector is dependent on electrons being affected. And so the question is can electrons detect this radiation if I do certain things to it, like I radically change the frequency, like have an uneven frequency. That is, some of the bits are close, some of the bits are far, and they're close and far. So if I mess up the frequency, can an electron react in a consistent manner, a way we can detect by creating a voltage and all of that stuff? I'd say that's an open question, and I'd say it can't. There has to be a certain consistency, a certain minimum. With our vision, we only count a photon if it has a certain amplitude. That is, a certain amount of it has to hit our retina. And so it means that either the ray has to be a long ray at a frequency, this would be a visible light photon frequency, or it takes more than one of these rays before our eyes register it. Now we can make devices like a photomultiplier that are much more sensitive than our eyes, and they pick up a lot smaller bits of the radiation. That is, a smaller stream of the frequency, but they're still dependent on a certain bulk to hit to create an electron motion and an electrical cascade of voltage. And so you could understand that we would have no way of really knowing that, because we can't measure the tiniest quanta of a photon. We can't detect it in its native form, or the elemental bit of the thing we call a photon. Again, we call it a photon because enough of it hits something. So by simply saying that if you had the energy but not enough of it, that is, the ray is too short, then that energy won't be interpreted by an electron, because it won't get pressurized enough to create a voltage cascade. So it won't be enough pressure. It'll move the electron, but the electron will just absorb the energy essentially and throw it back to the atmosphere instead of creating a voltage. Or it'll pass it on to other parts of the atom, the pressure, and it'll end up being converted into heat or some other form of radiation. And some of that's completely undetectable. So if what goes in comes back out again, and you couldn't see it when it went in, you're not going to see it when it comes out. So it's pretty easy to argue that gravity could be these kinds of broken chunks of energy. So the cosmic background radiation could contain not only chunks that are big enough for us to detect, that is, long hunks of radiation, but it could contain a bunch of short pieces of radiation that we have no mechanism to detect, and therefore it could be the actual source for gravity, because gravity is being affected by just the bits, not the frequency. It doesn't require a voltage to be created to be detected. It's just having a bulk effect, changing the momentum of the matter itself. It hits it and pushes it. So anyway, I bring that up just to point out that it's not that hard to account for the existence of an actual force for gravity. That it doesn't have to be a virtual thing, or we don't have any way of accounting for it. It doesn't have to be energy with no label. It's real energy, like the cosmic background radiation, and has a real effect. And it's conserved in the process of gravity. Take a break. Alright, I appear to be back. It's been a while, and so, sorry. Not that you noticed. So really, I shouldn't apologize for what you can't see. Whatever that is, that I didn't want. Stop that, whatever you're doing. Stop it. It's very convenient to have the menu pop up easily, but it's a little annoying. It doesn't know to go back if I don't use it. But anyway, alright. So I thought I'd get into the subject of energy conservation, and the idea that should be known is that there's only one universe, and it's the little universe. That's the big universe is just an expression, an emergent thing that pops out of the small universe, but it's the little universe. I've sort of stated it's, the school of fish is the fish. The school is just sort of a whatever. Without the fish, there is no school of fish. Without the nuclear bits, there's no planets, there's no other stuff that's going on. So all the real interactions happen on the nuclear level. So you can say that gravity is a nuclear force. It's not really acting on the Earth or on the sun. It's acting on the mass, the little bits inside the sun. And everything is doing that. All interactions are interactions on a nuclear level. They're not interactions on some other kind of level. So, so again, if we start with a universe that just had this force in it, okay, all of this random chaos, just a bunch of stuff, I've drawn pictures of it, but you can get the idea. Just, stuff moving in all kinds of directions, and in the end just being balanced. There's just as much stuff going one way as going the other way. And if you start with that idea of an empty universe just full of that stuff, and then you put a thing in there, he'll get hit by an equal amount of energy in one direction as the other direction. And you could sort of understand they would probably jiggle a little, move around a little bit, but he'd never leave this center. That the laws of probability would say he's stuck there, because there's not going to be any more energy coming from one side than the other side in the end. It'll all turn into the same amount of variance, so all he can do is be in some location within these probabilistic definitions of variance. But if I put two things in that world, then it gets more complicated, because then anything absorbed by this one, in terms of a little bit of motion in a direction, will be felt by this other one as a void in their world. Their world would say, I have less pressure coming from this direction because this guy's holding it, he's using it. And you use it to move. So to move a piece of matter, so the force is moving the speed of light. So it's going really fast from one place to another. But when the force connects itself to a matter bit, an electron or proton or something else, it's moving much slower in its world. And so the force obviously is in a sense used while it's attached to a matter bit. It's occupied, and it's changed now, because now it's not liberated. It's not going to get where it was going in the same amount of time, and therefore this is going to notice the absence. And then the catch would be, when this notices that there's less pressure coming from this way than this way, it's going to end up absorbing a piece of energy going this way, that is, trapping it, attaching it, and it's going to move this way. And when it does that, it's going to do the same thing to this other guy, which is it's going to say, I own some piece of pressure now. A piece of pressure that was going to hit you is now occupied moving me, and I'm moving much slower, so you're not going to get hit by it. And so this thing is going to feel that absence, and it's going to move into it. And so now, instead of just jiggling in a place, these two pieces of matter will end up being what we call attracted to each other. They'll move towards each other. And this is demonstratable. This is hard physics. This isn't something that's really in dispute as a plausible or real mechanism that happens if you can, in a sense, try to duplicate the experiment with the either simulations or with real world bits of energy. You can create something very similar to this effect. So the important thing to understand is how the energy is occupied or possessed or used. So Newton sort of made this point that something keeps doing what it's doing until a force acts on it. Now, implicit in what he was saying is, well, a force had to act on it to get to do something in the first place. So you're not really creating a force that makes something happen. You're really just undoing what has already happened in some sense. So in some sense, an acting force that's going to decelerate something or slow something down is really taking the energy it had and releasing it, giving it back to the bigger universe, putting the pressure back. So in a way, so what needs to be understood is that there has to be this conservation. So if something absorbs one of these little force bits, a photon for example, it essentially possesses that momentum. And so the momentum, you can almost think of it as sticking, like a piece of Velcro to the outside, however you want to think about it, but it sticks, it stays in it. And it stays in it in a sense, you can sort of just understand it as a trap. And so the trap can be inside of a little thing called the electron or the proton, but the trap can also be made of electrons and protons in terms of how the energy or these photons can be trapped between these little elemental bits, and they still retain their momentum. The trap means that they're, say it's a circular trap, means it doesn't go anywhere. You know, the energy is not free. Obviously, if you're traveling in a circle in a dead end, you're not going to feel like you're free to go somewhere. You're kind of just trapped. The road is circular, you just keep going in a circle. And the same thing happens to energy as it gets caught in these traps. But the initial momentum that they came into the trap with is still the real thing that's being possessed. That's the thing the object will have, is that original direction will still be something retained, as in that's what it has to give back when another force acts on it. So the idea would be is that a force sticks to something, the something moves, and that at some period in the future it'll basically stop moving. Should have a line for that, you know. So this is the moving object, some kind of line, I don't know. And then when it stops moving, it means it had to give the force back. So it has to give back, oh, wrong way. Sorry, it absorbed this, it has to give away that. So when it gives away energy in that direction, that means it's going to essentially decelerate or stop its momentum in this direction. You know, it was going this way, and now it gives back that energy, which means now it has less movement in that direction, so it moves less in that direction because it gave away that direction. So whatever energy it gives away, it has the effect of giving it momentum in the opposite direction, or in the case of decelerating, taking, you know, obviously the energy that was moving it is what it's giving back. I don't know how else to say that. So anyway, so that's the conservation law, is what you're really just doing is accounting for where energy is. So if a bullet's moving 10,000 miles an hour, it's because you put energy into it, and it actually possesses the energy. The energy didn't just kick it and say, now you're a bullet, you're going 10,000 miles an hour. The energy's physically, the photons, the little bits, are physically trapped inside the bullet. They're not going where they would have been going at the speed of light. Now they're just going 10,000 miles an hour. So you took some energy that was going the speed of light, and you basically converted it into energy that's going only 10,000 miles an hour, much slower. So even though the bullet seems incredibly energetic, it has less speed than the original energy that went in, and clearly some place forward to the bullet is now not going to be getting that energy hitting it. So there's even a gravity on the sense of the bullet is absorbing energy that would have gone somewhere else if the bullet wasn't carrying it. Yeah. So the space shuttle, for example, the big flame coming out, you have to think about it just being the opposite. It's going into the space shuttle. An equal amount of energy, so to speak, is being pumped into the structure, the material bits of the space shuttle, and the momentum it has that it gains from that huge flame going one way is just as real. It's just as powerful, and it's held inside the space shuttle. It didn't just push it, it's in it. It attaches itself to it. It collects it. The space shuttle collects the energy. It owns it. So you have to think of the energy as being trapped. But that's when something gains momentum from an interaction with energy, then it trapped that energy. It didn't just get pushed by it. It collected it in a trap, and it now owns it. And it has to give it back someday, maybe. It doesn't have to, but I mean, it can give it back. Someday it releases it from its, constant dead-end circle. Its cul-de-sac. And someday it can give that energy back and stop moving. And so that would be how you would look for conservation in any system, is to understand if there's energy going in and there's momentum happening to an object, then there's potential for that energy that is its momentum to be released. And that's what we see as the impact. When two things hit each other that have momentum in opposite directions, what we see is a mess made. We don't see them just cancel each other out in some way. They just hit each other and stop moving. No, they smash and crash and bash and create all kinds of releases of energy, because all the traps get broken and the little bits are free again. They're released from the cul-de-sac, and ultimately they have to be released in the right directions, but through the chaos of all the little material bits bouncing off of each other, there can be lots of waste energy. But the real energy is going to be in these two directions, the real energy release, and that's what's dematerializing the two objects, in a sense, is the fact that most of the energy is going to be released forward into one and forward into the other. So that's part of this conservation of the energy. So you can't have a graceful collision in the real world because there's too much energy that has to be released. It can only be graceful if there's a small amount of energy and a large amount of mass. Then you can have something called, a soft landing. Okay, so I think we'll pause and move on to the next bit. Alright, back. Change position. Chair sitting for a minute. Anyway, so I thought I'd better go over again this. It's a really important concept of how to understand the interaction between matter, bits of matter, electrons, protons, and such. Those are the two elemental bits, I would argue, in the sense of the only ones that are really playing the game hard, real players. Neutrons are more complex in the sense they're probably a composite of a neutron, a proton, and an electron, so they have the properties of both. And those things are going to be, they're being explained in this explanation. So the idea would be is to understand that when energy interacts with matter, this little quanta of energy, however you want to imagine it, whether you want to imagine it as a spring, a domino, hyperboloid, whatever you want to say, it has this property of being a bit of compression or energy. I think it's just as easy to think of it as a bit, as a little corpuscle, a thing of limited size that has a consistent momentum moving the speed of light. Anyway, so when it interacts with matter, one of these little bits that make up a photon, like I said, a photon would just be a row of these little bits at a frequency, what we call a photon. That definition leaves out, obviously, the idea that there could be bits at inconsistent periods. Sorry, not in the drawing. And the inconsistent frequencies wouldn't be something we would be able to see, because it wouldn't have the same, the electron wouldn't be affected the same way. But anyway, so when one of these little bits hits, the matter bit, you really have to understand that it's what's the matter already possesses is little bits, okay? In terms of it has an identity, a momentum, and its momentum is decided by what direction it's already collected. So let's just assume there's a certain number of collection points, and that for an electron, let's say, that doesn't move much or isn't moving much, that you could sort of understand that each one of these bits had an even amount of, they were all going in different directions, and that its momentum then would be neutral. It wouldn't have any bias in a direction. So like a school of fish, you could imagine that the fish, there's an equal number of fish swimming up as there are down, swimming left or swimming right at any one moment in time, and therefore what it possesses is no momentum. Now likewise, it could also in its current state have, you know, half of its bits of energy that it's collected, half of them could all be moving the same direction, and then it would have a clear bias in that direction and be moving in that direction some percentage of the speed of light, depending on how many bits are moving in that direction. So when a new bit interacts, what it's essentially going to do is replace the existing bits. So you could argue, a simple way of arguing would be that if this had a mixture in it, the bit that was going this way would be in this location because it's the furthest that way. And you could almost think of it as an exchange. This bit will replace this one. So this one will be set free, which means it's going that way. And this one will become attached, which means it will give this matter bit a bias. Now it'll have another arrow, so to speak, in this direction, and it will move a little faster in this direction. So it's basically just making an exchange. So when the force interacts with an electron, what it really does is make an exchange. Now if the matter bit is already had all of this, if it has a strong bias in a direction, then any interaction will release energy in that direction, which means you can't really add to its velocity, because it will collect a bit going this way and it will release a bit going this way. So you can understand that if this bit was moving this direction and a new bit comes in and hits it, it can't make any change. It's now just one more bit. It's just replacing itself with itself, essentially, and so nothing changes. And that sort of explains why matter bits can't go the speed of light. Is to go the speed of light would mean the matter bit itself would have to have zero mass, and more importantly, the collection of these bits, every single one of them, would have to be going the same direction, which seems unlikely in terms of as explained before, there's this field of energy constantly interacting, constantly making these replacements. So at any one moment there's lots of change taking place to the electron, and so it would be very unlikely that it could be maintain a velocity for any period of time anywhere near the speed of light. That it would have to be bombarded by a constant voltage, a constant amount of these little bits in a direction, a bias in that direction, to keep it going at a high speed. And that sort of is seen in experimental results, how accelerators work and whatnot. The particles do need to have their velocity maintained, by an introduction of momentum, force, energy, in the direction of the motion they're attempting to create. So it could theoretically has little probability of going the speed of light, and this is essentially the limiting factor. So again, this isn't necessarily how it physically works. It's just a diagram of how to understand that the energy bit is one energy bit goes in and another energy bit goes out. And the typical exchange will be what you take in, you give back the opposite of what you take in, generally speaking. In the case of an electron's interaction anyway, that would be what takes place. So you're making an exchange. This is the equal but opposite reaction. This is the Newtonian, the force acts on you, and the action of that force creates the reaction of a force in the opposite direction. So in some sense you could argue that this is a reflective mechanism, and that's all it really is. Any force that hits creates a reflection. The force leaves in the opposite direction, and the bit of matter moves in the other direction because it's exchanged energy going this way, something caught in a loop going this way, okay, for something caught in a loop going this way. So it's reversed the trap. It's trapped a piece of energy going exactly the opposite way. Trapped a hamster. You know, you could think of it as hamster wheels. And you have a hamster running this way. All right, and you run a hamster in, and he takes over, and he goes the opposite way, and the other hamster leaves. Kind of way of looking at it. Lots of ways to analogize it or metaphor what's taking place. So again, it's just really important to understand that energy is absorbed if there's momentum. So if the matter moves, it means it owns the energy. It means it took it and it gave back something likely going in the opposite direction. Alright, now if you added nothing more to the system that I just described, it would only superficially do gravity. It would create the momentum you need towards two objects moving towards each other as they absorb energy and deny the other object from receiving energy. But it does create a subtle internal problem that I'll illustrate. That's really important to understand how electrons actually function, and understanding how the underlying force is actually a repulsive force. The strong force is something called reflections, you know, and that those reflections end up amplifying in the sense that they end up being trapped and create a lot of pressure moving things apart, which you see in the atomic bits. And so you need a way, a mechanism to explain how these two forces that are being created by the same thing, these two effects, both attraction and repulsion, how they're regulated by the system, and being able to be expressed decisively. Very attracted, very repelled. I mean, very much pressure away from each other, very much pressure towards each other, and how those are the effects we see in magnetism and charge particularly. So I don't know whether this was an objection to particle gravity back in Newton's day, or later when Lesage was repackaging the particle theory of Fadio, but it creates a complication. So besides the problem of drag, which has to be explained, there's this other problem created by a physical, mechanized, kinetic particle theory. And that would be, you could sort of understand that two objects, yes, they would be collecting energy and releasing energy on the outside, and therefore they would be moving. They'd be exchanging momentum this way for momentum this way, and end up moving towards each other based on what they're getting hit from the outside. But the problem would be, as you could understand, if this is purely always reflections, and if the reflections are always usually reciprocal, that is, you give back to the field the opposite of what you stick, and you let go of something going the opposite direction, if that's the tendency, then obviously you can understand that energy, as things start moving closer to each other, that there would be a lot of reflections taking place between the two objects as they got closer and closer together. These interactions would be happening at a much faster rate. So as they're further apart, the cycle time between impacts would be rather large, and as they get closer together, the cycle time between impacts of those reflections would get much tighter, much higher frequency. So the energy between them would increase merely by changing the proximity. So you wouldn't be changing the actual number of bits being reflected back and forth like mirrors, but just by moving them closer together, and having the same number of bits, you would create more energy because there would be more impacts. And with each impact, there's a real change in momentum, a real obligation to move in a direction. Because you exchanged energy. You accepted something going one way and you gave back something going the other way. So with each one of these reflections, there would be a tremendous amount of pressure pushing the things apart, because now they have almost a perpetual energy source of reflection. So if you thought of it as a perfect mirrors, and you're started from a distance, you can understand that there's a bunch of energy that's coming in angles, and that those angles could create lines between the two things that would be almost parallel, and that as you brought the two things closer and closer together, all that energy would be trapped in between them. And again, it would be at a frequency that would be much, much higher, and therefore the amount of energy exchanges would be much higher per unit of time. So it kind of defeats the gravity. It would the pressure of the repulsive force as they got close would be so much greater than the external pressure pushing them together. The absorption of momentum in one direction would be overwhelmed by the reflective energy between them. The reflections would be a way of multiplying the energy, and it would be a much stronger. So that's a way of understanding electrons and why they repel each other, is that this is what electrons are doing. So although they have this idea of gravity, the gravity is defeated by these internal reflections, and that allows them to have a powerful amount of energy between them. And so that's the nature of the energy inside of an atom, is that there's a tremendous amount of pressure between the electrons. So they're attracted to a proton in the center, and I will now have to explain attraction, and they're repelled by each other. And it is the balance of those two forces that keeps the electrons where they are. And they don't need to be moving around. They don't need to have pressure pushing them in centrifugally or any of this kind of stuff. The magnetic pressure, the pressure of their repulsion, and their attraction to the center is all that needs to exist. So you can get rid of this whole spinning idea of atoms. You can include it if you want, but I don't think it serves any functional purpose, because all you're really talking about is positions and the tension between those positions. So I suppose I'll attempt a quick illustration. So you can understand that if there was 4 electrons and a proton, and there was an attractive force in, but there was a repulsive force between them, repelling the electrons from each other, you can sort of understand that this electron can't really move closer to the proton without creating more pressure here. So it's going to shorten the distance between it and these other electrons if it tries to move closer. So even though it wants to get closer to the proton, it can't. And this pressure pushing it out from the other electrons, although substantial, the pressure attracting it to the proton is still strong, and it will not leave the proton either. So it's essentially trapped in a tension, and that's all you need to explain why the atom maintains its shape, is that once you establish these relationships of pressure between the outside elements and each other, and attraction towards the inside elements, you don't need to create any gravitational force to maintain this configuration. You don't need to orbit anything at a velocity and the rest of that stuff. You just need these positions. Now, this makes chemistry make a lot more sense, in the sense that a shared electron would be literally shared. And so if I had another atom that was made of the same stuff, and they shared 2 electrons, for example, you could really understand how strong that bond would be, in the sense that these 2 electrons are in rigid positions. If you want to change the structure of this atom, you want to move it, you have to move both of these atoms because they're so rigidly connected, and they're connected in one location. So, and it also you can sort of understand that the spin idea doesn't really go anywhere, as an explanation, because then this atom would have to be spinning around the other atom, and that complex motion wouldn't be able to create much adhesion between things. As soon as you had 5 or 6 atoms stuck to each other, all the motion they were doing would get too confusing, and the whole thing would have to fall apart. So it makes it, I think, a lot more sense to understand that any motion electrons have are just the tension. That is, they're jiggling in position. There's a lot of tension, and they're Brownian motion. They're vibrating in that position because they're under extreme pressure, and that's all they're really doing, is vibrating. All right, so now I think we'll move to the modification, the subtle little change you make that makes all this work, that gets rid of this problem of creating both repulsion and attraction. If you just leave this force this simple, you have to give it a nuance. You have to give it a little bit of a change to make it possible to segregate the repulsion part from the attraction part. So that should be the next segment with a new piece of paper. Alright, now for the subtle bit. Not very complex, and strangely, conventional physics has so little answer for these questions in terms of explaining causes for the phenomenons of charge and magnetism, attraction and repulsion in those respective fields. Now, I would argue that the same field, I'll explain that, that's the same force. So they use a term called a virtual photon to explain this idea that a particle moving, a charge moving, creates a magnetic and electric field, a moving charge. And so they're sort of saying is what I've just explained, is that when something moves, it has to give back something to the field. And it does. And depending on its charge, it'll give back different things. So the idea of charge is just the idea that you have this thing called a plus and a minus. You could think of it as the north pole of the magnet and the south pole, that you have polarity, that you have two elements that are fundamentally reciprocal, in the sense of the magnet will show that to you. When the poles are lined up alike, they're repulsive through the mechanism I just explained in terms of the reflections are happening. And if I reverse it, the reflections stop happening. So if the poles are opposite, there's no more reflections apparently, then the two things are pushed together by the external high pressure and the internal low pressure. So they have no explanation. They just say the words virtual photon. They don't explain how the virtual photon creates the two effects, repulsion and attraction. They don't explain the polarity of the virtual photon. And they use the word virtual photon to explain something they call an electrical flux or field and a magnetic flux or field. But there's no details, nothing in terms of how this photon does this. So the only part I would argue they're getting right is they're recognizing that the force carrier, the thing that is the force, has to be a photon of some kind. That it's kind of obvious that the energy moves at the speed of light, that it has all the properties of what are traditional photons, and that it creates momentum and does all the things that photons can do. And so they're right in identifying it, except they don't have any way of making it work. They don't have any mechanism and can't describe how it does it. They're just telling you what it does, but not giving you any way of understanding why or how it's capable of doing that. So the simple argument is, and this argument is just so, it's almost so obvious, you say, why didn't anybody else think of it? It's just so obvious. So we sort of understand that protons and electrons are fundamentally different. Okay, so the electrons repel each other. So I would argue that I've given you some information about why that happens, but it's just basically because of this reflections that happen between them. And the protons are doing the same thing. And you could argue, you know, yes, they're doing it because there is, as I'm using this red color, I'm sort of giving it away, is because not only are there things that are plus and things that are minus as material bits, so there are charged elements. Electrons and protons have opposite charges. Well, the little force bits, the little things, okay, the little things moving the speed of light also have two flavors. They also come as elements of charge. Not that they themselves are charged, because they're not matter, but they're why these appear to be charged. These things wouldn't appear to be charged if it wasn't for the fact that the force has these two flavors of force, two poles, two what's the right word? Yes, that they have a polarity. See, polarity gets you in trouble, because then you get into the subject of polarization, which is fundamentally quite different. So it's a kind of a dangerous word. But okay, so what's happening when so now you can understand that, okay, the red bits get trapped between the protons, the blue bits get trapped between the electrons, and you can understand the repulsion that way. But what happens when a black bit interacts with a red bit? And the argument is that the interaction, that is the exchange, is fundamentally different. And what's going to happen is the bit that goes in, that's the wrong color, will not stick. So it can't be kept. And so what it's really going to do, though, is it will exchange momentum. So the red bit, just like the electron has black force trapped, the red bit has red bits of force trapped. And what it's going to do is it's going to exchange with one of those red bits its momentum. So a red bit is now going to change from going, say, this way to now going the direction of the black bit. And so it's still sticking, and it's going to change its momentum. And the black bit is going to leave with whatever the momentum was of that red bit. So in this case, I'm exchanging the same direction, which is kind of fuel to the conversation. But the tendency will be it will exchange in a perpendicular direction. So the black will leave perpendicularly. So you can kind of understand that if all the black energy leaves the proton perpendicularly, and all the red energy that hits the electron, okay, leaves perpendicularly, that you've gotten rid of any capacity to reflect. So no more of this energy here. There's no reflections, no perpetual reflections that happened with the electron and the proton, the electron on the electron, or the proton on the proton. So if all the red energy leaves through the electron perpendicularly and all the black energy leaves perpendicularly through the proton, there won't be anything trapped, and therefore there'll be a very low pressure in here. And the force I originally explained of gravity, any absorption of momentum, will just create this attractive force. This very low pressure creates, makes the external pressure stronger, and essentially explains why the two things will move into each other, because you've gotten rid of the neutralizing reflections. And that's what's so the big leap, the big change in your understanding of the mechanism is to go from the non-answer of the virtual photon, the non-explanation, to merely accepting that charge isn't a phenomenon just of matter bits, that the force itself comes in charged elements. And by doing that, by understanding that the charge starts with the force itself, then you can understand why the matter can get into these relationships of being attracted and repelled. So as a good way of describing it, just to understand, is you can just think about what a magnet's doing and why it can create such strong attraction and why it can create such strong repulsion. So when the two poles are opposite poles, you can understand, again, all the dark energy from this one. So the magnet is basically takes in all the energy from the external world. So the gravity, okay, the external pressure I spoke about before that's constantly bombarding everything. Well, that force is mixed. It's okay, it has no polarity, it's just randomly mixed. And what a magnet essentially does through this mechanism of these perpendicular changes to the opposite force is it essentially makes all the dark energy, okay, that hits the red end of the magnet, that energy will turn, come out this end, and any red energy that hits the dark end will be turned perpendicularly and come out this end of the red end of the magnet. And then any red energy that hits the red side, as I sort of pointed out, just reflects back. So, and any blue energy that hits the blue side just reflects back. So you can sort of understand that as this happens, any blue energy just leaks out of the opposing magnet. Any red energy just leaks out of the opposing magnet. Wrong color. And so so you can see that this would create an incredibly low pressure between the two magnets, and they would be pulled towards each other. And repulsion is likewise simple, but I might as well draw it just to be clear. And repulsion would just be the opposite. You're maximizing now the reflection, so you can understand that now when the mixed energy comes in, and the filter filters it, you can just see that now all the blue energy that's trapped between these magnets is trapped permanently. It's stuck. It can't get out. And all the red energy is stuck. It can't get out. It just keeps reflecting between the two magnets. So the closer you bring the magnets together, you increase the number of impacts, you increase the energy of the energy. And it's magnet is a nice word for it, because in a sense it's magnifying the energy. A certain number of little bits are in here, 1 million, let's say. But when you have the distance, you've changed those million into 4 million, in a sense that you'll have 4 million impacts now. So the energy of the same number of little bits is now increased because of the frequency, because of the number of impacts per second is increased. So proximity, in a sense, creates a kind of energy. So when you move things into each other, towards each other, you're changing their energy potential in a way. But it's still conservative, because obviously the higher pressure means there's a real motivation to move away from each other. So we understand that we've created potential energy moving out. And it's just like the atom example of the nuclear bomb, for example. There's a whole bunch of energy trapped inside of those atoms, inside of a single atom, in the form of those little reflections. So there's a tremendous amount of energy and potential there. So it took energy, took the pressure of the inside of the sun, for all the gravity pushing towards the center of the sun, all the mass. So the stuff in the center of the sun, you have to understand, it has the weight of all that material on top of it. It's like you having 1,000 people standing on your shoulders. They'll crush you. And so there's crushing pressure inside of the sun, and that's where the atoms are born. And so they're born in high pressure, and the fact is they're able to keep that because they're they're the right arrangement, the right geometry. They can survive when they leave that pressure. And if you do a certain little trick, you shoot a little neutron into them, you can force them to fall apart, and all of that pressure will be released. All of those reflections, all the energy that's trapped inside, in between, in those traps, this is essentially, these are traps. You know, once two magnets are placed next to each other, you've trapped a bunch of energy. You have to have some kind of physical mechanism to force the magnets to stay next to each other, because they are creating a lot of pressure moving them apart. You take really strong neodymium magnets, you have to have a whole bunch of very strong matter that's going to have a lot of pressure on it and have some heat and other effects to force the magnets to stay together, because there's so much energy trapped between them, so much pressure being created, and the pressure has real consequences. It's alive still, and in a sense that looks anti-conservative as stated, but it's clearly conservative in the sense that that pressure is now potential. So you've taken energy that was free and you've turned it into potential energy, and there's the clear potential for the magnets to fly apart is kind of obvious. If I push them together and hold them and then I release them quickly, I can make magnets move quite a distance. They can acquire quite a velocity, indicating that yes, the energy has been conserved. Okay, so that might be enough for this segment. Alright, I think we'll try to finish up with this segment. So just applying this notion, this idea that charge begins with the little bits. Polarization begins with the force. The force is charged. It has polarization. And all the other polarization you see is just a manifestation of that original polarization. The fact that the force, the stuff moving the speed of light, comes in the two reciprocal forms, the two forms that will have a reciprocal effect on protons and electrons because of their elemental nature. Now, in the case of gravity, why this effect doesn't have any effect is basically because of the idea of what makes things magnetic. And the basic rule is that something needs to align. Atoms can have a polarity, so I mean, I guess I should point out that the idea would be is that the atom has a structure, and that structure creates a certain, from a certain perspective, you'll see more of the proton or more of the electron. So you can sort of understand, depending on how these electrons are arranged, how far away they are, how close they are to the proton, has an effect on how much of the proton you'd be able to see. Just as I can sort of demonstrate that with something. I need something a little fatter than the electron, but you can get the idea that it can be completely blocked the closer the pen is to the object, and the further away I would go, the more of this would be visible. Vice versa, sorry. Obviously, the bigger I make the electron, the more this can be blocked by the shadow. So those effects, so you can have two ways to make the proton less visible, moving the electron in and out, or creating more distance between the electrons. Having less electrons obviously would create a different, what would be called a magnetic moment, or the probability of your view of an atom being polarized. So the idea is that atoms can have this kind of polarization, where one part of the atom can, from one point of view, can appear negative, and from another point of view it could appear positive. And you can do that directly by ionizing, that is, taking an electron away, which obviously makes the electron ring much weaker and would make the strength, the visibility of the proton stronger. So the idea is the atoms are expressing this polarity, and that depending on the chemistry or the makeup of the elemental shape of the atom, how the electrons are formed around it, there's some materials that essentially are more, you can line up these atoms, and when you line them all up the same way, they're all doing the same thing, which is converting the energy and creating the magnet. So a bunch of little magnets make a big magnet. Now in the Earth, for example, it's really hot, so all of the, even if there are atoms that are polar, that have a little bit of a magnetism to them, they're in such a hot environment inside the Earth that they're being jostled and moved around, so they never line up. So when the force has its effect, it all goes back to chaos. So instead of there being a bunch of segregation, that is a tendency for all the blue energy to go one way and a tendency for all the red energy to go another way, instead, because of the chaos of all these little domains, they end up just being mixed, and so you're back to just having the momentum argument. So the two objects just end up moving as if they had no polarity, and so you don't have this reflection problem anymore. And so that's gravity. That's why gravity is different, is because no element is an electron or a proton. The Earth and the Sun are not like proton and electron. They're not differently charged. They're the same charge, which means, which is a chaos charge, a no charge. And so the charge effect, which is the reflective part that only happens between electron and proton, is neutralized because the other effects of proton and electron are happening, and electron on proton. And so that's just undoing what the other force is doing, what the other effect is doing. So the only things that can be really affected by the pure attraction and pure repulsion are the things that are polarized, either in the form of monopoles of charge, the electron and the proton, or in the form of a dipole magnet. So I would argue that it's perfectly logical to consider the electron and the proton as the magnetic monopoles. They're the origins of magnetism, and that a magnet really is when these two things are connected to each other, close enough to each other, they become a dipole, or in essence a magnet. And if you can line them up, you know, electron, proton, electron, proton, electron, proton, you can create a powerful magnet. But it requires this alignment. It requires this, I should draw this the right color, you know, the pattern. You have, without the pattern, there's just chaos, and there's no segregation of the force, there's no magnifying of the force. Yeah, so I don't, the process of compressing atoms or moving electrons and therefore creating a polarity, and therefore you're creating a change in what force is being felt. So you can sort of understand that if I move electrons, then obviously I'll change what kind of radiation comes back out of the atom, you know, whether it's mostly black or mostly red. And that's the effect when they talk about a moving charge. Well, you're moving an electron, and when you move the electron, you change the disposition of the atom that it's part of, and by doing that you change what the atom is going to excrete in the direction that you created movement in. And so that can explain all of voltage and the effects of the fields created when they say a charge is moving. Charge doesn't really have to move very far, right? You don't have to change this much to change the effect of how the pressure is going to be felt from something viewing it from the external world. So this is all part of Maxwell's equations. Maxwell's equations has a lot of these ideas about you know, moving a charge closer or further away, and the fact that what something else sees, a third charge, so to speak, would see based on how far or close the charge is. So you could have a -5 charge here, and you could have a -1 here, I mean positive 1 here. The closer I bring the +1 to you, the more this becomes irrelevant, and vice versa. The more this becomes irrelevant, the closer I bring it to the positive charge. So if the two are this way, you're going to see a +4. If the two are this way, you're going to see a -1. Alright, so that's, I think, enough of a summation of the fundamental part of this. Again, I'm hardly doing anything extraordinary, in the sense that there's already an established source of radiation, the cosmic background radiation. I'm just arguing it's much denser in the frequencies we can't detect, and that it has merely it's polarized. There's two forms of it, and the two forms are perfectly synonymous with the two forms of matter bit. There's a positive and a negative. There's a red, there's a black, there's a magnetic north, magnetic south, however you want to describe it. and it accounts for the phenomena of both. What they call an electric field, there's no real such thing as an electric field. That's just another form of a magnetic field, and it has a different intensity based on the fact of how it's formed, in the sense that it's formed by changing surfaces rather than changing the density. And so this all really has to do with size and how you can project the force. So it appears like electrical charges have much greater power over greater distances, and they do, but that's because they're projecting the force from larger surfaces, generally speaking. And magnets are changed throughout the entire material, not just the surface. So I think that's enough. You know, and clearly in the case of creating a magnetic field by moving current through a wire, you're clearly changing the material. That's why the current matters. You're changing the atoms, so you have to interact with more atoms. So that means the higher current. Higher pressure means you're using less atoms to convey the electrical pressure, because you're getting more bang per interaction. The atoms are transferring more pressure, more little bits between the electrons. That's more pressure, that's more voltage. More bits is more voltage. And but if you have more current, it means you're using more atoms to do the transferring, which means now you've polarized more atoms, which means you'll get more magnetism out of the material, the conductor. And so yeah, so I think that's enough. Appreciate your attention. Like I said, nothing very, there's no voodoo here. You know, I'm not stretching credulity, stretching the realm of mechanical functions. It's very simple, and clearly in a contest, in an Occam's razor contest, this simple explanation creates a much more vision. It's much more sensible than saying something like virtual photon, and it's certainly better than saying something like bent space. And so this simple mechanism can account for all of the bent space phenomena, and it can account for, in my opinion, all of the quantum mechanical mechanisms where energy is transferred by anything called an electromagnetic wave. There are no waves, there's just stuff at a frequency. And frequency was just vibrations, and vibrations are momentum exchanges, and that's all that's taking place. So, thank you for your attention, and I will eventually do a part 2 that does more detail about the conversions of magnetism into electricity and vice versa, and how electricity really shouldn't be thought of as anything but a manifestation of magnetism more than its own force in and of itself. It's not something different, it's quite the same. In terms of the force part of any electric field is the same as a magnetic field. It's just a change in how much black to red, how much positive energy versus negative energy is being excreted by something. So the energy is always the same stuff. It's not changed when it's electric or when it's magnetic. It's the same little positive or negative force, red or black force. Proton force or electron force is probably the best way to state it. There's an electron reflective force and a proton reflective force. So just as a throwaway, all of the electromagnetic spectrum affects electrons, so it's all really made out of the black force, effectively. The effective part of any photon radiation is in the form of electron-sensitive radiation. Okay, so I think that's enough. So, yes, long video, nice little experiment anyway, and so till the next time, and such. And, you know, so I did it over a whole day period, and no failure. It's probably a dangerous thing to do, because yes, you can lose everything if the computer fails in some way, but Linux seems pretty reliable. I don't have any system crashes, at least not on this computer, and so this might be worth doing and such. Till next time.